Hi everyone, today we're going to be looking at the Productivity Open P1AM Industrial Arduino Watchdog Timer. Now, detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. So up on my screen we have ProductivityBlocks opened, and if we look under the P1 setup, and going down, you can see we have the Configure Watchdog, Start Watchdog, Stop Watchdog, and Pet Watchdog. So let's take a look at the Configure Watchdog. Now remember that a watchdog is just a piece of code that will time out when an error occurs in your program. And it will usually cause a CPU program, or in our case a sketch, to stop or reset. So in the configuration, we set the milliseconds for our watchdog timer, which we've set for 500 milliseconds, and our toggle is false. Now, if the toggle is false, then the watchdog time will stop the CPU until you power cycle that unit. We can also change that to true, and if it's true, then the watchdog timer will automatically reset the CPU, so your program will then try to run again. So, two different options when you look at the Configure Watchdog. Then if we look under the next instruction, we have the Start Watchdog. So this instructs it to actually start our timer for our watchdog itself. Then we have our Stop Watchdog, which is kind of self-explanatory. It will actually stop that watchdog timer from executing. And then finally what we have is our Pet Watchdog. And the Pet Watchdog basically refers to resetting that time so that it does not time out. So usually that happens at the end of our scan, or it can happen when we are truly expecting a part of the program to take longer. We can pet it so that it will reset, so it will never time out, so we won't get that error. So that is our instructions in our productivity blocks for the watchdog timer. Now if we look at a program, and this program is what we did last time. You can see here, what I've done is just added the watchdog timer into our program so that we can tell what's going on. So the first thing we do is in the setup, you can see that we configure our watchdog. Again, we set it for 500 milliseconds and we toggle it to false, which means that it will time out and stop the CPU until you power cycle. Then what we do is we start our watchdog during our start setup. Then we do our subroutine initialize. And remember, our subroutine initial actually sets our previous milliseconds. We set our CPU light to low. We set our points to 0. And we set our shift register to 0. So then what we do is we do our subroutine check. So our expansion modules. And on our expansion modules, we actually are doing a while statement, and we do a roll call on our individual cards. We have 4 cards currently in our hardware, and if all the cards are present, everything's fine, it continues. If it's not present, then what we do is we blink our CPU on and off, and we also stop our watchdog timer. So we'll stop that so that we can just continuously execute these commands. Next, what we do is we will look at a loop condition, and that loop condition is actually an if-else. So if the CPU is on, then we set our CPU high, our LED light, and then we get our points, slot 4, then we do our watchdog time. This allows us to actually time out. So we're actually using the P1 module blink. So we're going to blink on for 500 milliseconds and off for 1,000 milliseconds. So on for half a second, which is the same length as what our watchdog timer is. So what that'll do is actually cause us to create an error in the program. So, and that's off of slot 4, which is our simulator input. And the 4th bit over, which is the 3rd switch. So that's where that's what we actually do. So third switch, if it's greater than 0, it's on, and we start blinking, it'll cause our watchdog timer to time out. Then, as discussed before, we have our start-stop circuit on switch 1 and 2, and then we have our shifting bits on and off. So this turns on a bit and shifts it through every 500 milliseconds. And then else we do our subroutine initialize, again checking our cards or zeroing it out, so and turning off our CPU. Then what we do is we pet our watchdog at the end of this cycle. So every loop we pet our watchdog to make sure that it doesn't take longer than 500 milliseconds. Then we check our cards, make sure they're still present, and that becomes the end of the program. So we can just verify that program. And as that's verifying, what we can do is look at the hardware that we have here. I'll just call this up. There we go. So you see we have our Productivity open, the P1AM-100, and we also have included our digital I/O cards here. So we have our 16 relay output, we have a combination input output, and we have our simulator switches here. So we have the exact same program, everything's running. And so what we'll do is, the first thing we'll do is just upload that program into our controller. So let's just connect it through a USB, and then what we'll do is transfer this program or upload it. And there we go, we're uploading, and it'll be done in just a second here, which is done now. So now you can see that my program is running, and if I were to that's my stop switch, turn on my switch, you see my output turns on. Then take my start switch off, stop switch, the second one, it turns that output off. So everything seems to be working as it should. My bottom switch here, switch number 8, turn it on, and we will actually see our output just cycling through back and forth as our program does for our shift register. So if we turn on switch number 3, what that will do is it will go into that part of the logic that we talked about before here, right here, and it will delay, on delay for 500 milliseconds and off for 100, so, or 1000. So let's turn that on. And as soon as we turn that on, you'll see that my program just stopped. All the outputs turn off, and I have now a flashing base product. Now, it says here that I need to cycle power in order to allow this to run again. So let's turn power off to the CPU. There we go, we turned it off. Now let's turn it back on. And you see what'll happen is, again, as soon as it powers up, it's going back into the same mode and blinking. That's because we still have switch number 3 on. So let's turn switch number 3 off, so it doesn't cause this part of the program under Watchdog timer to actually be on. Cycle power. There it is, off again. Let's turn it back on. And as soon as the base powers up, we're in run mode, LED lights on, and everything's working again. We can turn off our shift register, turn it back on again, and it's running. We can do the on off. So that is working again. So that is our Watchdog timer within our controller. And the reason why we do that is to ensure that we know exactly what's happening within that logic. So if anything takes place that we need to stop the execution of the logic and turn off the outputs, that's what we use. So a very important instruction is the Watchdog timer. Now, if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us, or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.